Today, in this video lecture, we will see another numerical on strain, energy and impact. In this numerical, we will find gradually applied stress and suddenly applied stress also. We all know that for gradually applied stress is load upon area, and for suddenly applied stress is 2 into load upon area. So these are difference between gradually applied load and suddenly applied load. And in numerical, they have given us dia of this steel rod. That means this is steel rod of diameter 80 mm and length they tell us 5 meter long. And find the maximum instantaneous stress induced when a pull of 160 kilonewton. That means this is 160 pull. That means tensile force 160 kilonewton acts on this steel rod. Material they also tell us this is steel rod. See, and this modulus of elasticity E is property of material. This is physical property of material. E is equal to 210 GPa, and this E GPa convert this into MPa because we require units in Newton per mm square. This MPa, that means 1 MPa is 1 Newton per mm square. And in this numerical, our problem statement is this: for sudden, gradually and suddenly. So this P we have this 160 kilonewton, this area also the diameter pi by 4 into d square, and also instantaneous elongation calculation is added, delta L. So delta L for this is different and delta L for this is also different because delta L formula is sigma L upon E. So stress is equal to modulus of elasticity is equal to stress upon strain, and E into delta L upon L. This is change in length upon original length is equal to sigma. So the change in length is equal to sigma L upon E. Yes, this is right. Just for this formula calculate here. So this sigma, due to this sigma, both delta L changes. See, first for gradually applied load. Right, like stress for gradually applied load. So it's P by A, and P is 160 kilonewton. Convert the kilonewton into Newton. 160 into 10 to 3 Newton, and upon area is 5 by 4 into dia is 80 mm, 80 square. Circular section area is pi by 4 into d square. So this is 31.83. Newton per mm square, and change in length for that gradually applied load is stress into length upon E. Stress is this 31.83 and length is 5 meter, that means 5000 mm, and E material property 210 GPa, that means 210 into 10 raised to 3 MPa. So 31.83 into 5000 divided by 210 into 10 raised to 3 is 0.76 mm. This is change in length for stress due to gradually applied load. and this is stress for gradually applied load. Now next, suddenly applied load. I had tell you in our previous lectures that what is gradually applied load, suddenly applied load. So due to suddenly applied load is 2 times gradually applied load. So see, don't need to calculate this because this is just 2 times, that means 2 into 31.83. Directly you will get value because load, tensile load and area is same. 2 into 31.83, P by A is 31.83. This is 63.66 Newton per mm square. And change in length is sigma L upon E. Sigma is 63.66 multiplied by 2000 upon E. E is 210 into 10 raised to 3. So this delta L is 63.66 into 5000 divided by 210 into 10 raised to 3 is 1.52 mm. So, and they also tells us that comment on result. So see, for gradually applied load, change in length is 0.76 mm, and for suddenly applied load, change in length is 1.52 mm. That means suddenly applied load, change in length is 2 times gradually applied load. See this 0.76 mm, 0.76 into 2 is this 1.52. So, and this stress is also 2 times gradually applied load. That means this gradual suddenly applied load is 2 times gradually applied load. As stress increases 2 times in suddenly applied load, see, gradually applied load and sudden applied load, the stress is also 2 times this gradually applied, like 2 times gradually applied stress, and delta L is also 2 times delta L. This is also due to gradually applied change in length. So this is the relation between suddenly applied load and gradually applied load. So thank you very much.